Hi, everyone. Welcome
Hello.
on this fine Friday, California morning for me, is the only frame of reference I have. Oh,
Hey, people are coming. This is
I,
great.
again, I love the waves. Thank you for waving. Or I guess raising your hand, but it seems similar. Wow, if you want to put in the chat, I really like to see it. So if you want to put in the chat where you're coming from in the world, feel free to, because I love seeing our grand distribution here.
Huh.
Oh, wow, everywhere.
Nice.
Is it still cold in Wisconsin, or have we finally made it past being cold in Wisconsin? I feel like we must have made it past by now. It snowed in Wisconsin today. That's nuts. That's crazy to me. Uh, yeah, I've lived in California my entire life, which like there are parts of California that have real weather, but I've lived in the parts that don't have real weather. So I truly the concept of snow is just foreign to me.
Oh, Istanbul. That's cool. I was just in Istanbul, I guess a few months ago. It was an amazing place.
Oh, really?
I had a great time.
Wow. Right before quarantine.
Yeah, right before.
Good for you. Getting out. Oh, wow. Hi, everyone. Oh, more symbol. Wow.
We're just going to wait a few minutes to let people join, and then we'll get started.
Oh, I'll start giving same spiel I gave last time. One, very nice to see a couple of you who came last time and are coming again to rethink through these concepts. Good on you. It's I think especially with images and the math we saw was a little brain bending. So get excited, everyone. It's going to be fun. But yeah, the problems we're talking about are pretty cool today. But hopefully many of you have found the chat already. The way we've been doing sort of interaction is like formal questions that you have, you can put into the Q&A section, and we'll try to get to as many of them as possible. We'll like answer some of them live, we'll answer some of them directly. You can like go through and upvote questions that you think are useful or that you also have. And then the chat, we like can kind of monitor, but like it's possible if you don't put questions there because those might get buried, unless you just have like a general question and you want other people in the chat can answer it. So if you have just like what, and you think that other people in the chat might be able to help, like people in the chat, feel free to answer each other's questions, interact with each other. We love that and are happy about that. And then we will also have a couple like polls that will happen over the course of it, which will also be a chance for you to sort of check your understanding. It's like our 3 different modes of interaction here.
Yep. Very good. And yeah, we're just going to go through some stuff that will hopefully be helpful for the assignment and life in general, to do with images and functions.
Yes, images will change your life.
Will change your life.
They're pretty cool, I will say. We're going to see some very fun filters today. So, oh, and in terms of what we're going to cover today, so we will do a brief, well, semi-brief, like conceptual overview, which will be a good chance to like, if there's anything you're still confused about, like we are happy to talk through it. So that'll be a good chance for you to like make sure that you're on the same page about all the concepts that are necessary for this homework, and then we'll do the practice problems. But we'll talk about functions and images in our conceptual review. So hopefully that'll be useful.
Hopefully.
Hopefully, fingers crossed, We heard last time it was, but no one could ever say. And to answer Sean, we are not going to specifically go over any of the problems in the homework, but we are going to go over a problem that is like adjacent to or similar to Warhol. So the idea being that hopefully you'll be able to build on whatever you learn from these practice problems and apply them to your homework. So I think we will do stuff that is useful.
Cool. Should we get started?
Yeah, let's do it.
Okay. Let me share my screen. Okay. Let's do it. So here we are.
I have assignment help.
Can everyone see my screen?
Yep, looks good to me.
Okay, awesome. So yeah, like Maya said, we're doing a cool, quick, well, not quick, but a comprehensive conceptual review of the kinds of things that are going to be helpful for the assignment. So namely, we're going to talk about functions and parameters and returns, because they're like the bread and butter of programming. And then we're also going to go over images and go through some practice problems with images. So it's really exciting. So we'll start off with a little conceptual review. I'll start by talking about functions. And as we go through this, please feel free to keep asking questions in the Q&A, in the chat, and we will try and answer them at the end of each section as much as we can. So cool. Okay, so the thing I want to talk about is that we've been teaching you about these really cool things called functions. And these are really this powerful, powerful idea in programming. So it's really worth understanding what a function really is. So you can think of a function. Here we have a function with some name, some parameters, and it returns some result. And the way you can think about a function is it's like this kind of like, I don't know if you remember this Clippy thing from Microsoft Word, but you know, it used to be like this helpful little robot that would do things for you in Microsoft Word. So you can think of a function as just like this helpful thing in your program. And what this helpful thing does is it says, if you give me some information, like if you give me a first param and a second param, I will do something useful with it and then give you back an answer. So the way a function works is you give it the information it's asking for, like the parameters, in this case, first param and second param. You give it some values and it will do what it was made to do and give you back an answer. That's what all functions do in kind of a high level. Okay, so this is very abstract. We should talk a little more concretely. So we're going to go through a very small example. This is a function you saw in lecture. It's a function called getAverage. It takes two parameters. It says, give me these two pieces of information and I'll give you their average. What are the two pieces of information? A num1 and a num2. Okay, so how would we use this in a program? Well, remember, this function is this kind of helpful little robot. You give it a num1 and a num2, it gives you the average. So here we have a little main program. And this main program, we're going to go through line by line. So we start on the line. And to evaluate that line, Python calls the getAverage function. And it's calling the getAverage function with 3 as the first parameter and 5 as the second parameter. So that means what gets pasted into num1 is the value 3, and into num2 the value 5. So we're saying, hey, little clipboard robot thing, get me the average of 3 and 5. And it says, okay. It goes and gets the average, figures it out, however, and it gives you back the answer, which in this case is 4. And then what happens is that answer is what gets assigned to the variable average, AVG. So we called the function, it did what it had to do, or what it was made to do, it gave you back an answer, and now we assign the value that it gave back to this variable average. So we get a variable AVG with value 4. Okay, very good. So let's do a very similar but slightly more complicated example. Again, we have a function, the same function getAverage, and we just have a different main program. So this time, rather than hard coding 3 and 5, we're going to generate 2 random numbers and then find their average. So here we have the main, we do our first line where we create a random int, and we get a random int, we store it in the variable first, which you can see down here in the bottom left. Then we create a variable second and store it in the variable second. And then we say, get me the average of first and second. Now what this is saying is, hey, helpful little function, for your first parameter, I'm going to give you the value of the variable first, which is 6. For the second parameter, I'm going to give you the value of the variable second, which is 10. Go do your thing. And then this function says, I know how to do an average. You gave me 2 numbers. The answer is 8. And it returns the value 8. And that value is what gets assigned to the AVG variable. So on the next line, we have put the value 8 in the AVG variable, average variable, and then it prints it. Yeah, so that's kind of how we think about functions. There are these kind of helpful boxes or humans or robots or whatever. You give them some information, they do what they were made to do, and they give you back an answer. And the way you give them information, the way you give them information is through the parameters, and the way you get back answers what they return. Okay, so any questions about this? Its name is Clippy, yes.
Yeah, we're huge fans of Clippy over here.
Had any questions?
Looks like so far people are good. Feel free to pop questions in the Q&A if you have any.
Yeah.
But for now.
Yeah, if you want to give a thumbs up too, saying everything's good, that's fine too. Okay, cool. Oh yeah, okay. Raised hands, I will take as a thumbs up.
We love the raised hands.
Yeah, we are really like, we use raised hands to mean anything we want to do.
Truly anything at all in the world that we want. I will interpret them at will, depending on how I feel, is my plan.
Okay.
Okay.
So,
yeah. So I think I'll present and share my screen if that's okay, just so that I can draw on it easily.
Yeah, it's great.
Share screen. Boom. And let's go down to here. All right. Can everyone see this lovely rendering of an image here? Nice. Thank you. I love the raised hands. Fantastic. Okay. So images. Images are really fun. I think they're like the first point where we really start to see just like the incredible applicability of the knowledge that we've built over the course of this course, right? Because like you look at the fairly not simple, like there's a lot that you've had to learn in order to be able to like work with images, but just the explosive like possibility space of what you can do to promote these images now that you know what you're doing, which is just so incredibly cool. Like you can make them sepia, we saw grayscale, we saw like highlighting weird colors and filters, and there's so much more we can do too that we'll see today. So I just think images are so cool. Anyways, but under the hood, images basically are just a grid of pixels, right? So it's height is the number of rows and width is the number of columns. And under the hood, this would be like a 4x4 grid. And within there are a bunch of individual pixel values. And each pixel value is essentially just a collection of 3 numbers. It's a red number, a green number, and a blue number. And so we can basically mess with this image by going in and manually messing with each of these pixels, changing what their values are in order to, permute the image and end up with these cool results. So let's just review some syntax for that first of all. In terms of making images, there's 2 ways to like make an image object that's available to you to like mess with in your code. The first way is to read in from some file name. So you can do like image equals simple image dot file name. And then the other way is to do image equals simple image dot blank and then pass in what you want the width and height to be. So in this case, the order does matter of function arguments. That's actually just always true. The order does matter. And so this, even though they're the same, right now it's just going to do a 200 by 200, so we could swap them, but it's always width and then height. So if I wanted like a 100 by 300, like column skinny thing, then it would need to be 100 comma 300. And then properties that are relevant that we can grab. We can't like directly edit these, but we can like look at them and use them is image.width and image.height. So those will just, give us basically back the information that we put in of like how wide is this image and how tall is this image. Okay, so a very important skill, which we will use a lot today, is looping over pixels and images. Because odds are there's like a lot of different things that we'll be able to do by looping over and visiting every pixel in an image once. So the way that we do that is there's basically 2 different ways to loop over an image. The first one is what I'm showing here, where you basically have 2 for loops, a nested for loop. And the idea of this nested for loop, which I think is actually worth thinking about because nested for loops are whack. This is going to be, this y value over time is going to be set equal to every row in the image, right? So like this is going to start out as 0. And then we're going to have this inner for loop, which is going to run once for each row. And that this inner for loop is going to be set equal to every possible row value. So this is going to be 0, then 1, then 2, then 3, or every possible column value, excuse me. So this is going to be column 0, column 1, column 2, column 3. So basically this outer for loop is here. We have 1, 2, 0, 1, 2, 3, right? And then then we sort of exit this for loop, go back up to the top, and now this value becomes 1. So now we get to row 1, and then we repeat this inner for loop of 0, 1, 2, 3. And then we go back up to the top, and this becomes 2, and we're here, and we repeat 0, 1, 2, 3, and so on. And that's how a double for loop is able to make progress and loop over this image. So the thing to note here, a question that we got last time, which I thought was a really good question, is can I swap the order of these loops? Does that matter? And the answer is yes, you absolutely, you can do whatever you want, actually. It will totally still work if you swap the order of these loops. The way that they're ordered right now, we're doing this sort of top left across to the bottom right traversal. If we were to swap these two for loops, what ends up happening is instead of looping over the rows sort of first, we end up looping over the columns, because we say, okay, 4x is like our outer thing. So we're going to start at, column 0. And then we say, okay, well, rows are going to go down this way. So this would basically just change the order of what our traversal is going to look like. So that's the deal with this double for loop. That's the process that we're taking here. And that basically gives us all of the different X, Y locations in this grid. Then once we have those X, Y locations, then we can use this, which I'm going to get into in a second, but we can basically make a call to image.getPixel. And that's going to basically give us a little arrow pointing to whichever pixel we currently care about, so that we can mess with it and do like pixel.green equals something. Okay, great. So that's the double for loop. Let me clear this. And great. So images continued messing with pixels. So once we have this like image.getPixel object, then basically what we're allowed to do with it is we're allowed to permute its red, green, and blue values. So we can like do pixel.red equals 0. We can do pixel.red equals pixel.green for some reason we want to. If for some reason we want to, like copy paste that value or whatever. Your imagination is the limit. You've got power. The other way we have of messing with pixels is a really interesting one, which I think is a little tricky to get practice with. So let's consider the case where I have 2 images. So I have this one here, and it has, actually we'll just do it with one image. I'll pick the same example I had last time. So let's say this has 9 pixels, and all of them are the same, are black, except for this bottom right one, which is red. And let's say that I want to write a function which copy pastes whatever value is in the bottom right pixel, and basically copy paste that pixel value to all of the other pixels in the image. So I just want it to become a single pixel color. It's as if I took the fill bucket and I like filled everything else after like sampling from the bottom right corner, right? So the way that we would do this, let me rearrange my screen a little bit here. First things first, we would want a reference. We want a variable that gives us an arrow to this pixel so that we sort of can look at it later, right? So we would do something like our pixel to copy equals, and we would do, let's say that this is called image, right? So this means that we've already gone through the process of like reading in from a file. We've already made our image that's saved. We would do image.getPixel. And in this case, our XY would be 2, 2, right? Because that is the bottom right corner. But we could make it more general by like doing whatever the width is -1 and whatever the height is -1. So this is 2, 2. Okay, so now what this is giving us is an arrow to this bottom right pixel. So now we basically can look at it and mess with it if we want to. So then if I then wanted to copy paste that pixel's values into all of the other ones, then I can use this call image.setPixel. So image.setPixel is mostly just like a syntactic sugar is what we call it. It's like a nice helper function that saves you some work, because we could do this we could simulate this functionality with a call to getPixel which, and then like manually setting all the red, green, blue values. But this is just a slightly shorter way to do it. It's nice because it saves us some work. But basically what this lets us do is it says, okay, I'm gonna pass in the X and Y of the pixel I wanna change. So like if I passed in 0, 0 here, and then I'm gonna pass in the basically an arrow to some pixel whose values I wanna copy paste over. So in this case, I could pass in pixel to copy. And what this is going to do is it's going to take all the red, green, blue information from this one and copy paste it onto this one. So it would overwrite this such that it becomes a red pixel. So then if we want to repeat this a bunch of times, then we want a for loop over all of the pixels. So we can do our our double for loop here. We could do the for y in range height. Oops. Image dot height, and for x in range image dot width. And then we can just call image dot set pixel on all of these different locations. So we can just call image dot set pixel of x comma y, and then the pixel to copy. So I see a great question in the chat, which is, could we do this with a for each loop instead? So a for each loop is the other type of loop that I forgot to mention, so thank you for remembering, which this is the double for loop, right? Where we like manually sort of visit each location and then like use the X and Y. And the question is, could we do this with instead a for pixel in image? So actually, I'm curious what people think. Why don't you put your thoughts in the chat? Can we do this same functionality with this type of loop, where basically pixel is going to get set equal one at a time to all of the different pixels in the image? Okay, actually, this is really good. I see a lot of, I see actually some controversial, this is a controversial question. I see, because a lot of people are saying yes, because it does visit every pixel in the image, which I absolutely agree with. But there's a question of here, this image.setPixel call requires an X and a Y, right? So I can't really use image.setPixel here because I don't know what the X and Y is of this individual pixel. It's that's like a hard question for me to answer. So what I could do instead here is, instead of trying to call image.setPixel, now I just manually have access to the pixel instead. So I could do, you know, pixel.red, oops, not G, that's not how you spell, red equals pixel to copy dot red, because these are both things that I have access to. So I absolutely could accomplish the same goal of image.setPixel, but I would have to manually do it each one, for each color. So the important takeaway here being that for pixel in image doesn't give me access to the XY. So because it's basically doing the overhead for us of like giving me an arrow here and then giving me an arrow here and so on and so forth. So if you care about the XY, a double for loop is probably the way to go. If you don't and you just want to do something with every pixel in the image, then for pixel in image is a really nice sort of syntactic sugar that can help make that a little cleaner. Okay, let me save this.
So, yeah, this is great. Just a few questions. So firstly, yeah, there is a way to get X and Y using a for each loop using pixel.x and pixel.y. But the idea is, like, if you need the X and Y, you should use a double for loop. If you just want to do something for each pixel, you do a for each loop. Okay, so there were good questions about, okay, firstly, does the pixel act as a simple variable, or is it predefined that it refers to the pixels of the image? So, yeah.
Yeah, fantastic question. The answer is that pixel is not a special keyword. Pixel is just a name that we like, that we think is descriptive, that we've been using. But I can absolutely say like P2 equals image dot get pixel, or I could say, you know, cat equals image dot, it wouldn't be a good naming scheme, but I could do it. So you're absolutely welcome to name it whatever you want. Like that variable name isn't sacred. It's not predefined to, I could do pixel equals 4 if I wanted to. That's just a name that we think is descriptive, which we have been using. But really good question, because that's definitely not clear.
Yep. We talked about that. Yeah. Okay, here's a question. Well, two questions that are related. Someone asked about like, how do we figure out what position to access a pixel when it's not just 3 by 3, it's some like arbitrarily shaped image.
Like how do we scale our logic?
Yeah.
Great. So I will address that in two parts, because you're right, that is a super good question. So let's go back to this sort of example where we wanted to grab the bottom right pixel. The bottom right pixel is like a particular location. It's good because we do have some point of reference for it, right? Where we know that the bottom right pixel is always going to be at whatever the image's height is, -1, and whatever the image's width is, -1. Specifically because of the way that indices work, because of the fact that we start out at 0, 1, 2, 0, 1, 2. This is, the height and width are both 3. So convince yourself that this is always going to be basically the height -1, or it'll be width -1, comma height -1, -1, comma height -1. And so that's in terms of grabbing that last pixel. That's how we would basically, make our reference much more generally useful. So then the second question is, what about sort of the rest of the pixels? And that's where we get into the usefulness of this like 4x and 4y in the range, because these are guaranteed to eventually be every value in the pixel. So it's a really nice property of them is that they work regardless of what the image actually looks like or what its relevant sizes are. So this is the more general, like how do you eventually get access to all of the pixels, and this will work regardless of size. And then whenever you're trying to get a specific pixel, like you want the bottom right corner, or you want the top left corner, then you have to think about, how do I do this in relation to the values that I know? So how do I do this in relation to the height and relation to the width?
Yeah.
And I saw another good question. Oh, go ahead.
I was just saying that, yeah, so the idea is like you use your programming knowledge to kind of do it generally for, like, that's really the challenge of these questions. Like, and we'll get practice with this today. So
absolutely.
Okay.
Just another question is, can the width and height be modified for a given image? Very good question. So I'll tell you the boring answer, and then I'll tell you the fun answer. The boring answer is that, well, first of all, don't do image.width equals something else. I don't actually know what the behavior of that will be, but I expect it will not be what we want it to be. So these are just for reading. Just don't worry about trying to change those values. Boring answer number 2 is there actually is a function in the image library that we're using, Simple Image, which lets you like scale an image different ways. So you can check the image reference handout that's linked from the assignment page if you're curious about that. But it's useful if you need to like scale an image in some way. That can be a useful feature. But fun answer is, we're actually going to do a problem where we look at under the hood how scaling works. So stay tuned for the second half of the session where we'll do a practice problem about scaling different ways. So stay tuned for that.
Okay. Cool. I think that's most of the questions.
Good stuff.
What if you want to copy the cover?
Ooh, okay. Actually, we'll talk. That'll also come up later when we're talking about Stretch. So that's another good question.
Okay, great. So I think maybe we should start with the first problem. Could you go to the next slide?
Oh, yes, I can. Let me clean this up here.
So we're going to do 2 problems. The first one is really fun. It's called monochrome, and it's this really artsy filter, which it takes an image, and what it does is it makes it look really intense by making all the pixels either black, or completely black, or completely white. And how it does that is it says, so there's the filter. And how it does that is it says, let's go through the original image, and if a pixel is sufficiently dark in the original image, we set it to black in the new image. And if it's not sufficiently dark, we set it to white. So we're going to go through all pixels, and depending on how like sufficiently dark they are, and we'll explain what that means, you set it to black or you set it to white. So we're going to write that right now. And again, please keep asking questions as we go.
Yeah, the questions are great. That's what we're here for. That's the point of this. So,
yeah.
Okay, I'll stop sharing so you can share your screen.
Brilliant. Okay, so okay, here we go. All right, so here we are in our wonderful PyCharm window. Can everyone see this?
Yep, looks good to me.
Nice. Oh my God, I took over my screen. So many raised hands. Okay. All right. So yes, awesome. So let me just describe this problem a little. So we're going to run this monochrome filter, and we have a comment here explaining what this does. This program applies a monochrome filter to an image by making all pixels that are dark enough into full black pixels. And a full black pixel is just when the red value is 0, green value is 0, and blue value is 0. And any other pixel that doesn't meet this dark criteria, it will turn into fully white, which is given by a red value of 255, blue value of 255, and green value of 255. And so what, okay, great. And what does it mean for a pixel to be dark enough? Well, we're saying a pixel is dark enough if its average pixel value, like the average of its red, green, and blue components, is less than 128. Great. So we're going to write this code over here, and like always, we're going to start with pseudocode. We're going to think of a high-level plan before we go in and write any real code. So what are some good steps we need to do to solve this problem? So we have loaded our image up here, and we now want to sort of change these pixels. So we have some high-level idea. We can say, well, go through each pixel one by one. And then for this pixel, as we're going through these pixels one by one, if the pixel is dark enough, then what do we do? Well, if the pixel is dark enough, we set pixel to be black. So that's great. If the pixel is dark enough, we set it to be black. And if it's not dark enough, we just set the pixel to white. This is our entire program pretty much written in pseudocode. This is great. It's something you could show a 5-year-old and they would understand what's going on. Okay, so
Brilliant 5-year-old.
now, yeah, brilliant 5-year-old. Yeah, so now that we have our high-level plan, we just go ahead and start trying to implement. So we need to go through each pixel one by one. And we know a couple of ways to do this. And the question is, what do you think is the better way to loop through these pixels for the kind of problem we're trying to solve? So hit up the chat with your answers. Great. Okay. So yeah, great. A lot of answers. So we have a lot of for each loops, and some people saying we could do a nested for loop. So we could definitely do either. There's no problem. But because in this problem, we don't particularly need to know the X and Y positions. We just, for each pixel independently, need to change its red, green, or blue values. We can just use a for each loop. It's a little simpler to write. So yeah, great. Okay, so we can say for pixel in image, right? So for each pixel in the image, what do we want to do with this image? Well, I'm going to write this code, and remember this pseudocode right now. So if pixel is dark enough, if the pixel is dark enough, yes, a lot of people are saying we should calculate average here. We can do that, but let's stick to our high-level plan. Our plan was saying if the pixel is dark enough. It wasn't saying compute the average and then do it. It's just saying if the pixel is dark enough, plain English, set the pixel to black. Well, we know how to set the pixel to black. We can set its red value to 0, its green value to 0, and its blue value also to 0. My indenting is being weird. Okay, great. And what we're saying is if it's not dark enough, then we set the pixel to white. So we can set it to white. So that means setting the red to 255, the green to 255, and the blue to 255. Yeah, so great. So someone asked a really good question. Don't we need to like, what's this dark enough thing? Like, don't we have to do something there? And it's right. Yeah, exactly. We have to do something here. I'm writing pseudocode right now. So you can say we're saying like, we need to do this line. We need to make it actual code. But right now we're just writing as much as we can and we'll get to it, right? So we've done most of the program. We said if the pixel is dark enough, whatever that means, we'll get to it. Set it to black. And if the pixel is not dark enough, then we set it to white. Okay. Now, yeah, now there's this elephant in the room of like, well, this isn't actual Python code. We just wrote something in English. But the beauty of programming is we can write something in English and make it a part of the code by defining helpful functions. Like, wouldn't it be, so yes, so wouldn't it be so cool if we had something like, if we could just say, is pixel, or let's say, is dark enough? And we just gave it a pixel and this thing magically told us true or false, this pixel is dark enough or it isn't, right? And that is just the beauty of programming. We don't have a function like this, but we can make a function like this. So what we can say is we can define a function is dark enough. This function is like that little clippy thing. We give it a pixel and it tells us true or false if that pixel is dark enough. Okay, great. So we've used the function. We do actually have to define it. So we go to the bottom and we say, okay, we define a function is dark enough. It takes a pixel and then it returns true or false, okay? So we give a little description, returns true or false based on whether pixel is dark enough. I see a question saying, does it matter if I define this function before or after main? No, it doesn't. It's up to you. Okay, so we need to implement this function. And there's some logic to this function, but why don't we just try and test the code we have so far by doing something really basic? We're just going to say for now, every pixel is dark enough. And so if we say every pixel is dark enough, what should this program kind of output when we run it? So we're running this on an image and we're saying every pixel is dark enough for now. What will the output image look like? Yeah, hit up the chat. Nice, okay, a lot of great, yeah. So a lot of people saying the image will be totally black. So why is that? Because we've said if a pixel is dark enough, set it to black. And right now we're saying every pixel is dark enough. So it's not sophisticated, but it'll do something. So let's try running it in the terminal down here. So we say Python monochrome.py and we run it. And it should, in theory, my computer is very slow with images, so it'll take a second. It just outputs a completely black photo. And just for reference, the original photo is this one. So great. So it just outputs a black photo, which is awesome. That means like most of our code is working, just that is pixel dark enough is a little messed up. Similarly, just for fun, if I change this to false, if I say no pixel is dark enough, what output image would come out? Right, exactly. So it would be just a pure white image because we're saying every pixel, no pixel is dark, so everything gets set to white.
You're killing it today. Great work.
Yeah, people are doing great. Okay, so it's great that that stuff is working, right? Now we can be kind of confident that at least our logic here on setting black and white is fine. We just need to write this one function. Okay, great. Right, so awesome. So we just have to write this one function. So again, we do the same strategy. We're writing this function. What are the high level steps? Now people were saying, yeah, we compute the average. So we say compute average value of pixel. If this average is greater than 128 is what the problem said, then we return true. Otherwise, return false. Okay, high level plan. Now we go implement it. So we compute the average value of the pixel. We know how to do this, but again, in the spirit of sticking to our plan, we can say something like pixel average equals get pixel average of the pix. Yeah, so we can do it in one line. We can actually write the red plus green plus blue divided by 3. But we want our code to read like English. Like we want it to read like the pseudocode. So even for something as simple as that, we'll make a helper function that will take the pixel and return the average. Okay, so we have pixel average. Okay, and then we say if pixel average is greater than 128, return true. And we say if it's not greater, if it's less than 128, if it's dark enough, return true, else return false. Okay, so again, we have most of our code written. We again are relying on a helper function, which we haven't written yet, but we kind of have a conception of how we want it to work. So now we can go and write that. We can say define a function get pixel average. It takes a pixel. And what does this function do? Describe it first. This function, okay, so this function returns the pixel average of the given pixel. Okay, so great. So how do we do this? Now, this is just a one-line function. We know how to compute the pixel average. We say, we return the red value plus the green value plus the blue value. And we divide by 3. We do integer division because pixel values, like these red, green, blue values, are always integers. Okay, and it's great, right? Like a lot of you might be thinking like, wow, we just decomposed this one-line function. We could have written it over there if we wanted to. But my point is, which one of these pieces of code will a 5-year-old, a 3-year-old, I don't know, a Labrador retriever understand? You know, it's the one where it's written in English. It reads like English. We're saying pixel average equals get pixel average of pixel. That's way more intuitive to read than pixel average equals red plus green plus blue, you know. So you get to make these design decisions. Okay, great. So someone said, shouldn't we make, oh, okay, someone made a really good point. I'm not gonna say what they said because it'll give away my question, but if we read this code, everything kind of makes sense. We're saying for each pixel, if it's dark enough, set it to black, I'll set it to white, and is dark enough says compute the pixel average. If pixel average is less than 128, return true. Okay, what does this 128 mean? Like as a human, that's just a number to me. It means nothing. Like you're just saying if pixel average is less than some random number that I have no context for. So what we should really do is define a constant that's descriptive. So we could say if pixel average is less than some constant called the dark threshold. It's a very intense sounding name for a constant. And then we'll define this constant up here and we'll say dark threshold is some value like 128. And now we can play with this value. We could make it more or less strict. Okay, so we have a pixel. Okay, let's review the code. We are setting pixel to black or white based on this condition. Let's see if it works. So we're going to run it. Exciting. It's running slowly but surely.
Oh no.
Oh
also, another comment read decomposes. Oh, gorgeous! Yay!
So great. Look how artsy that is.
I know we're artists, team. We did it. We're killing it. But yeah, another comment read decomposition and why like breaking up these functions is a good idea. One, it reads much nicer as we talked about. But two, what if I wanted to do something else with the average of a pixel? Like what if I wanted to like compute the averages of all the pixels and then like to maybe find the biggest average and use that as my top threshold, like do something more interesting with it, right? Then the fact that I have now have a like get pixel average helper function makes that so much easier because it means I don't have to copy paste that line of code. I don't like doing the logic for that. I can use that same logic in multiple places, which means that our program is already like 10 times more powerful because all of a sudden we have the capability to do things in different places at different times. So another argument for why decomposition, even if it's a seemingly small task ends up being like a lot, it can end up being used a lot of places. And so it's always worth decomposing.
Right, exactly. That's a really important point. Like get pixel average is something you could use as many times as you want. It's its own kind of conceptual unit, right? Like you'll notice one of the section problems requires you to get a pixel average. And again, you could write out this division by 3, but it's just nicer to have a function that just gives you the answer. Okay, very good. Someone asked a great question. What happens if we mess with this threshold? So if we make the threshold lower, so we say you have to be really, really much darker than 128 to be considered dark. What would we expect our output image to look like? Just for reference, originally, so when it was 128, it looked a certain way that I'll run. Yeah, and people are saying like, yeah, if we make this threshold stricter, we say you have to be way, way darker, like to be considered a darker. So this is the original. If we change it to something like 40, what's going to happen is less pixels in the original image will get considered dark. And so there'll be more white spots, like it'll be brighter or like less dark than the original one that we made. So let it run for a second.
She's doing her best, that's for sure.
Where is it? Yeah, so you see there's a lot more white in this as compared to the original image. Exactly.
Oh,
so we get to play with this, and people, yeah, you can do interesting things with the threshold. Like you can set it to the max brightness of the image, as someone suggested. So all really cool stuff. Okay, so that's our problem. Just before we go, one thing I want to try is some other cool images. I'll change this back to 128. Okay, we have some fun images. We have the Scream painting, and then we have this Joker picture, which is nice. So we can try out Scream.jpg and look cool. We'll also try out Joker.jpg. So this is Scream, very artsy. And now we can try Joker. Also looks great. Nope. Come on. Slow and steady. Look, so we have our Joker photo. It's a cool filter. You can play around with it, write your own. It's a fun time.
Yeah. So a couple questions that I saw that were, I think, really good questions. So if you go into some of your helper functions, you had like pix in some places and pixel in others, and people were asking, how does the computer know that like pix is equal to a pixel? What is the difference between those two? What's going on there?
Yeah, so I very purposefully kept these variable names separate to make a point that, like, remember, this is a little helpful paperclip in your program, and it says, give me something for this parameter px. You can give it whatever you want. Like, it could be a variable up here called pixel that you pass to it. It could be something else. The point is, like, the function doesn't care what you called this variable in your code. It's just saying, give me a value to use. And so whatever value you use, it will take px to mean that value, right? So it doesn't matter that the variable names have to be the same or anything. This is dark enough, will take whatever value you give it, whatever pixel, wherever it came from, and it will compute this is dark enough logic on it.
Okay, good stuff. Another question that I'll just answer. So we will be, I saw this a couple of times, but I'll address it broadly. We will be releasing the code that we wrote today after the session is over, along with our slides and along with a video recording of one of the sessions. So you will have access to all of this afterwards if you want to like pour over the code and ruminate and meditate on what good decomposition looks like.
Yeah, great. Okay. I'm going to stop sharing.
Okay. Oh, and actually one other question I saw that's good, which I just personally love to talk about because I'm studying computer science for my degree, and I'm on what's called the systems track, which is like the low level sort of how does this all work under the hood track. So I saw some questions that were like, is it a lot of overhead? Does it make the program slower if you have a bunch of functions that you have to call? And is a for each loop faster than a double for loop? So is it faster to do for at each pixel in the image versus 4x and 4y in the image? So both very good questions and very interesting to think about. The long and short of it is that the notions of like faster, it really depends on the problem that you're thinking about. So it does add a little bit of overhead in order to call a function. Like that does actually require a couple extra instructions. But in terms of extra instructions, it's like 2 extra lines. It's like one additional jump, basically, which, you know, if you are curious, learn about assembly, go forth into the good night and study all of the crazy under the hood stuff. But the long and short of it is, technically, yes, it's a tiny bit slower, but a computer runs so many instructions so quickly that the additional like benefit of like it's negligible. It's literally not noticeable to a human. It's not visibly distinguishable. It's too small for us to like be able to comprehend. And so but the benefit is huge because we end up with much more readable code. So the answer is technically yes, it is a little bit slower, but not functionally, especially not in Python where things are slow anyways.
Yeah, and I can also say, like, just from personal experience, even in industry and stuff, like if a trade-off has to be made between fast code that's hard to understand versus slightly slower code that's way easier to understand, 99.99% of the time, your engineering manager will say, do this one.
Yep.
Because the hard thing about writing complicated code, it's about writing sustainable, easy to understand, easy to test, easy to modify code. It's not about getting the like seconds out of your performance, you know, shaving milliseconds or something. Sometimes it is, sometimes it isn't.
Right.
Okay.
But very specific applications.
Okay.
Okay, so I will go ahead and share my screen now. Cool. Can everyone see presenting? Yay, thank you everyone. It gives me a little green checkbox in the corner when you raise your hand, and it just makes me so happy. Okay, so the next thing we're gonna do here, we're gonna do another image problem, but it's a slight variation on what we did before. Because what Ali just did was this awesome, like applying this awesome like black and white monochrome filter where we went through and changed the value of each of these pixels in order to get this cool effect. But that was basically just looping over an image that we already have and just changing each of the pixel values based on some filter. So the other type of thing that we can do with images is construct new images, is like take a base image and do weird things with it to like change the size or like tile it or whatever, and end up with newly constructed images. And that's another whole new like tool to add to our toolbox of like different powers that we superpowers that we have for messing with images. So the problem that we're going to do today, which is again not the same as problems on your homework, but will help I think a lot with like reflection and Warhol, is a problem called stretch, which I will, rather than telling you what it does, I will just show you. This is the effects that we're going to be achieving today. Is basically we'll take an image and we're going to scale it to double its size in the X direction specifically. So we're going to make it wider. And we'll play around with making that more versatile. But yeah, the idea is that basically if we like look closely at this, we're gonna have to sort of, there's like more pixels in the right image than there are in the left image. So we're going to have to be clever about how we're copy pasting these pixel values over, because it's not gonna be quite as simple as just like one-to-one. So I actually, on that vein, we're going to start thinking about whenever you have especially an image problem like this, where you're like, wow, this is a crazy effect. I have no idea where to start. The first thing to do is take a much smaller example and say, okay, given a very small, like maybe like 2 by 2 pixel image, what is this effect doing in that sense, like in that specific example? Because it's much easier to reason about like 4 pixels than it is about 1,000. So I'm going to put up a question. Don't put your answer in the chat. I'm going to give you a poll to do, and you'll have plenty of time to think about the poll. So like take your time, sit on it, and decide what you think is the right answer.
Yeah.
So let's launch this. So this is basically another version of the Simba question. Is I have this original image ABCD, and I am curious which one you think is the correctly stretched image. So take a minute or two and just sit and think about it. And how are we copy pasting these pixels over in order to fill all the empty space?
So just to clarify, the A, B, C, and D are each a pixel.
Yes.
And we're asking when we stretch it, obviously, like we need to fill up those extra pixels somehow. And it's like, what's the right way to fill them up if we kind of stretch it horizontally? Yeah.
Exactly. And I'll share the answers with you afterwards so we can see what people thought. Okay. We're about 2/3 there, so another like 30 seconds. And in the meantime, if you've already answered, start thinking about what effects do these other versions have? Like what is accomplished by each of the other filters that are applied here. Okay. All right, we're at about 80% now. So I'm just gonna go ahead and end the poll and we'll talk about it. So y'all killed it, great work. The answer far and away was C, which is good because I put B in there to trick you. So really good work there. If we look at what each of these are doing, so C is doing exactly the thing that we wanted, right? Where it basically just took the original image and it sort of stretched everything vertically twice. So A now has sort of 2 copies of itself, C has 2 copies of itself, and they're all still arranged in the same order, right? So C is exactly what we're looking for. If we look at these other ones, they're also interesting. In this case, the first option here does actually an effect very similar to something you might be thinking about on your homework, which is basically it takes this entire image and it copy pastes it twice. So instead of sort of stretching them and keeping the original composition, it just literally copy pastes it. So it takes up the same amount of space, but the pixels aren't next to each other anymore. So you end up with this nice like tiled image, right? D does exactly what people said. It just zooms in. I think it's exactly the right answer. D is definitely what we're going for here. But yeah, D basically just takes A and just zooms us in on that point, or just copy pastes A everywhere else. It's a lot like what we were talking about early on in our process, where we like take a pixel and copy that pixel value, sort of like the fill tool. And then B is kind of interesting. I don't actually know what B would look like. That's actually, if somebody wants to code it up and show me, that'd be cool. But B basically takes each of these and gives them a column. So it's not quite a vertical stretch. It's because a vertical stretch would look something like A, B, B, C, C, D, D, right? Where we do the same effect, but sort of stretch it in the other direction. This, I'm really not sure what this is doing. It's basically like taking these and like making them columns. So you're gonna end up with this weird barcode kind of deal, which is maybe a cool effect, but definitely not what we were going for. So really good job, everyone. I will stop sharing these results and close this. So great. So now we've done sort of the first part of our thinking here. Ding, yep, C is exactly the right answer. So we have a high level idea of how we're approaching this problem, and that we kind of need to like take these pixels and like copy them twice like next to each other. And so I think the thing to do now is now we have to get into like an actual, like a more specific look at this problem, right? We can't just say, great, copy everything twice. That's a good high level strategy, but it's not quite the nitty gritty details that we need. So I'm gonna give you another poll. And this is a tricky question. I'm telling you right now, it is not easy. We saw last time, but we were split evenly between 3 different options here. So take your time to think about it. But the question's gonna be basically given an individual pixel. So given something like B, how am I going to figure out, pretend that I'm only dealing, well, actually, I'll just show you the slide. That'll be the best way to do this. So yeah, pretend that I'm only dealing with drawing these individual columns, right? So I'm only doing this column, this column, this column. I'm just basically getting this like halfway point where I'm not gonna copy everything twice yet. I'm just sort of figuring out where each pixel's range is gonna start in the new image. Let me launch this poll. And so the question is, which of these is going to correctly calculate B's new position based on sort of its original pixel location? So B is starting out at 0, 1 and ending up at 0, 2. What is the right like formula for figuring out where B ended up in our new stretched image?
Yeah. And do remember that like one of the skills we're trying to impart in this help session is that when it comes to image problems and figuring out these coordinate transformations, you should draw it out and really work through it on a piece of paper to figure out what's actually going to happen. So it's not at all like, oh, you should just see this and, you know, see the right answer in your mind's eye or something. You have to draw it out and, you know, maybe try out some cases and see the general pattern.
Right. No, the reason that I made these slides like this is because I also had to figure out the math of like what is happening here. I had to draw it out. Don't get me wrong. This is not for you. This is for both of us. But I do think it's really interesting, like images in particular, especially when you're changing their sizes, reasoning about where things end up and like how that math should work is difficult. It's very hard. So always the piece of paper with like 2x2 images or like 2x3 images is the way to go. That will just always be so much easier. So take your time here. I'm going to give you like a full another like 2 minutes. Draw it out on paper. Do some of the other pixels. Like think about what if I instead have like A here? Like does the formula you choose work for the A case? Or like C here? Where's that C going to end up? And does it work in that case? And so think about, yeah, take time to ruminate on what you think the right answer is here.
Yeah. Maya, is there a way to restart a poll?
I don't know. Actually, I might be able to.
Because I'm curious if we try a 3x3 and see if the answers are.
Ooh, okay. If we like take whatever answer we got for the 2x2 and then we say, okay, now think about a 3x3. I might be able to. I'll try. We'll see after I end this polling. But only half people have submitted yet, so I'm gonna give everyone a chance to still think about it and take your time. So if you already submitted an answer, hang tight. You might have a second chance. But again, start thinking about what if you had a 3x3 image instead of a 2x2? Does your answer still hold?
Yeah. So we're trying to figure out like if the old pixel was at 0, 0, like the A, where does it end up in the new image?
Mm-hmm.
So in this case, the 0, 0, A is ending up at 0, 0 in the new image. The 0, 1, B is ending up, the 0, 1, B is ending up at 0, 2 in the new image. What would 0, 3, the pixel 0, 3, if we had a 3x3, end up at in the new image?
Where we're being a little inconsistent. This is y comma x. But
sorry.
Yeah, no, you're good. It's because it's row column, but it's y x. It's just a whole thing. So I'll just put that there to be clear.
Okay, cool.
Okay, we're about at 70%. So everyone go ahead. I'll give you like 10 more seconds. Toss in your vote. If you just guess now at this point if you haven't yet, and then we'll talk through the answer here. So, okay, last couple of votes trickling in.
Nice. Okay.
Perfect. Okay, I'm gonna end this poll and I'll show it. So this is really interesting. We got a super good distribution here of we're almost evenly split between A and C, and then also a lot of people thinking B. So really good thinking. Like I said, this is not an easy problem. This is why we draw it out on paper, because I think it is a super tricky thing to reason about. But let's sort of go through here and let's take a look at each of these and figure out sort of whether or not they apply in the way that we want them to. So I'll stop sharing these results so they don't keep popping up for you. So let's take them in order from least to most votes. So in this case, x plus 4, it had a good run. It was doing its best, but we can already see, right, that like the x value going from 0 to 0 in our A case, and then also from 1 to 2 in our B case. This is like A, this is B, and this is some unknown pixel D, or maybe E. So we can already see that that's not going to work in the simplest of cases, right? Because it's just moving over by too far. So it's not D. So then the next one was, it was B, I think, was the next second lowest. So B is really interesting because if we look at specifically for our pixel B, this actually does seem to work, right? Because we were going from, oh no, it doesn't actually, not quite. But we were going from 1 to 2 here. And so it looks like, you know, it does kind of look like we're sliding over maybe by 2 pixels. But if we look a little closer, it's interesting because A doesn't move at all, right? Because A is going from x location 0 to x location 0. And then B is going from x location 1 to x location 2. And it stands to reason that, you know, some fake pixel here, E, is going to end up at some location 4. So then we're going to end up with 2 going to 4. So as much as x plus 2 looks like it kind of right, it does look like we're sliding over by that much, it's not actually accomplishing what we want it to do. It's not going to work generally for all of the different pixels. So it's not B, but good guess. That was a tricky one that I threw in there to fool you. So then the next most common answer was we have basically the difference between 2x minus 1 and 2x. Looking at this, not doing any math, I would totally believe that either one of those is right. They are very much very similar. And this is why we say like draw out pictures and like draw out examples, because I think that just looking at this picture, it's totally unclear which of these would be true. But when we start actually applying examples, so we say like, you know, for pixel A, we're going from 0 to 0. And then for pixel B, we're going from 1 to 2. And for pixel E, we're going from 2 to 4. We start to see that like if it was 2x minus 1, this would take us to -1. So that's actually going to be out of bounds, right? And 1 would take us just back to 1 because it would be 2 minus 1. And then 2 would take us to 3. So this is going to be what we want, but shifted over by 1. So because of sort of the 0 index idea, we don't end up needing to do this -1. The correct answer is in fact A. With our just our scale by 2x. So again, very tricky problem, super, super interesting. And so I think that you all did a really good job reasoning about this. Congratulations on getting A at the end by a slight majority. But again, if you got a different answer and then went, oh, I was wrong, shoot, that's actually good. That means that you're making progress in your thinking and like you're watching learning happen. So making a mistake and then realizing why it was wrong and getting a better answer means that it's actually the best thing you can do, because it means you have a more thorough understanding of the problem afterwards. So if you got it wrong and now understand why this answer is right, that's the best thing I can do for you. That as a teacher, that means I'm winning. So fantastic work. Hopefully this is clear.
Yep. Yeah, so once we do this, the question is something obviously we're going to talk about is like, how do you fill the rest of the blank pixels?
Right.
Yeah, sorry.
Oh yeah, go ahead. Yes, so we will, that's actually a really good question. So let's maybe think about it in this example. How do we fill in the rest of these blank pixels? So what we just got is that sort of, we want to copy paste each of these pixels over from whatever its like X location is to its 2X location. So that's going to take this B here, it's going to put our A here, and then it's going to put our C here. So I didn't set up a poll for this, so maybe just think about it in the chat. But now the question is, for this second pixel, how would I get the X value of the second pixel, like the second location that I'm copying the pixel to? Because I'm going to copy it twice, right? Because I'm scaling by 2. So the question being, what gives me this, these individual pixel locations? Oh, I see so much good thinking in the chat. Yes, team. Take a second. Don't look at the chat if you haven't answered yet. Think about it. How might I go sort of 1 over from wherever I started? Oh, wow. I love watching learning happen. This is fantastic. Okay. So as a lot of people in the chat have said, exactly right. If this location is 2x, then our next location is going to be 2x plus 1. So, which I think is actually a really cool idea, right? Because the idea is we're copying each X location twice. First to sort of its normal location slid over, like however much, like placed and interspersed into this bigger image. And then also 1 over from that, because we're literally just defining the range at which we want to copy each of these pixels over. So this notion of like a +1 right afterwards, I think is exactly right. Of just like slide over by 1 and like also get the one next to me. And then we've successfully copied over into our range. So fantastic work. Okay, keep this in your heads, but we have a strategy now. We know vaguely what we want to be doing here. So this is fantastic news. So now I'm going to dive into some code and we will go from there. So, okay, can everyone see my my PyCharm? Thank you, everyone. I wasn't sure which screen I shared, so this is good. Okay, great. So now we notice, first of all, let me walk you through what I already have here, because this is going to look pretty similar to what I literally copy pasted from another file in your homework. So now if we take a look at what's happening here, basically I have this main function. And what main is going to do is it's going to sort of show the original image. And then it's going to call this makeStretched function. And it is up to makeStretched to return, basically, for now we can have it as a default, return image. And what makeStretched is going to do is it's going to take this original image and it's going to scale it up. It's going to make a new image, which is equivalent to the original image, but scaled up by 2. So oops, that doesn't need to be there just yet. Great. So the idea is that, yeah, this is going to take in and scale it up by 2. And then our main function is going to just call that function and then show the results at the end. So, okay, let's go ahead and dive in. Let's tackle a high level strategy here of like how we want to think about this image. So why don't we put in the chat which we're definitely going to need to loop over all of the pixels, right? We saw that sort of for each of these, we need to like copy paste it over. So put in the chat whether you think a for each loop is the right strategy, or whether we want a nested like double for loop here. Yeah. Ankit, I agree. Is the right answer. Fantastic. Okay. So a lot of people in the chat are saying that we want a nested double for loop, which I absolutely agree with. So because of the fact that in this instance, we care about what the X and Y are, right? Because we saw we had to do X and then like a 2X later down the line, which means necessarily we're going to need to know what that X is. So we're going to want a double nested for loop. Nested. So that's maybe redundant. It's probably just a whatever, it's fine. So we'll double nested for loop over sort of all X's and all Y's. So now we sort of have access to the X and Y at each location. So now the question is, once we have this X, Y, what do we want to do at a high level? Like what's the next step, right? Which we saw was basically copy over the pixel, copy over whatever pixel we were looking at into sort of our new image. So copy over pixel into new image, maybe twice. So now this is basically our high level strategy, right? It's not so bad looking at it, but we have to translate this into actual code. So then the other thing that we need to do, don't forget, is we're making a new image. We're actually returning a different image than our original one, right? So we want to do something like result image equals a simple image, and then we're finally going to use our dot blank here to make basically this is going to be the new width, and this is going to be the new height. So, more upkeep, we're eventually going to return this result image because we're finally constructing new images because we want them to be of a different size. So now the question is, okay, what size should this resulting image be? Because remember, we have image, which is sort of our reference point here, which is like the thing that we're copy pasting from, and we're copy pasting into result image. But what should result image's new width and height be in relation to image? Wow, thank goodness I have you all to write my code for me. Honestly, what a blessing. Great. So I see a lot of people saying we basically want double the width and the same height, right? Which makes a lot of sense because we're going to copy each pixel over twice and the height's going to stay the same. So we basically just need enough room to make sure we have room to copy each pixel twice. So we want to do 2 times image dot width, and then whatever the original image dot height was. Oh. Uh-oh. Okay, good, we're good. And so this is always going to be in the order width, comma, height. Fantastic. Okay, so moving on. Now we basically just have to write this double for loop. And we have sort of our new image here. We're feeling really good. We have our old one, we have our reference one. So next step, once again, put your answers in the chat. Which image do we want to double for loop over? Do we want to double for loop over image, or do we want to double for loop over result image?
Awesome.
All really good questions that you have to, address when you're programming. It's like, oh my God, which image do I care about? Which one am I looping over?
Yeah.
Great. Okay, so I see a little bit of back and forth between whether we want result image or image. So I think that this is actually a really interesting question because the answer really is you could do it both ways. If I was looping over result image, what then I have to do is I have to basically, I'm at some location in result image and I have to sort of backwards calculate what the original pixel was that I should be copying over, which in theory we could do. But the way that we did our math, we started at a pixel in the original image and figured out where it should go. So we probably want to loop over the original image just because that's the way we constructed the problem in our heads. It's entirely possible we could have like divided by something in order to find the original pixel going from result, but we have been thinking about it in terms of copying twice from the original one. So we want these to be over image dot height and image dot width. But really good thinking because you can do it either way. Okay, last but not least, we're like truly nearly done here, team. Now all we have to do is just copy over the pixel into the new image. So we are finally going to use that famous call that we talked so much about in the review of we want to set a pixel inside result image, right? Because we just want to copy paste whatever the pixel was inside of image into result image. So actually 2 steps that we need to do here. First of all, we need to get the pixel inside of the original image, right? So we need to do, maybe pixel to copy equals image.getPixel at x comma y, which is exactly what we've been saying. And now we need to result image.setPixel. So there's 2 things we need to do here. We need to tell it which pixel we actually want to set, and then we're going to copy over pixel to copy. So last time in the chat, what do we think this X and Y here, remember, are the pixel inside of the new image. So inside of the stretched one. It's like, what is that new X and Y location that we're copying over into from our original image? So it's very similar to the math we did before. Pop it in the chat. What do we think this X and Y of this new pixel should be? Okay, good stuff. I see a lot of really good answers. So everyone pretty much agrees that this should be at Y, right? Which makes sense because what we saw before is that we're always staying at the same height because our height of the image isn't actually changing. So then I'm actually seeing an interesting split between our 2 options are 2x and 2x plus 1. So let's just try both of these and let's see what happens here. Right, yeah, because I see. So what people are saying is we, the first copy pasted, like both of these are actually valid because it depends on sort of which one we're doing. Are we doing the first pixel or are we doing the second pixel? So actually what I'm going to do is I'm going to leave it as 1 for now, and we're going to run our code in the middle, and we'll see basically what result we get. So let's start out with just 2 times x. And we'll not worry about copy pasting it twice now. And in theory, if we run this, we should see, yeah, exactly what we expect to see. So we've only copied over sort of half of the columns, right? Because half of it is missing, exactly what Giorgio said. So this is exactly what we expect to be seeing. We've only sort of copied over those left columns. And so we're seeing this nice little like shower curtain picture of Simba. Where half of the image is missing. So I agree with what everyone said. We basically need another call here to do this time 2 times x plus 1. So now if we run this, yay, we see a stretched Simba. Woo! Okay, but we're not done yet. This is a huge accomplishment. We're winning, team. We're really on a roll here. But the question is, curveball. What would I need to change if instead of stretching it twice, instead of stretching it by 2, what if I wanted to stretch it to 3? So what if I wanted it to be 3 times as wide? What in this code would I need to change? Why don't you put your thoughts in the chat of like how we might adapt this code in order to be 3 times? Okay, I see 2 really important thoughts. So I see people saying we need this new image width to be 3 times image width, which I absolutely agree with. And then we're saying, okay, maybe replace these 3s with something. So let's run this and see what happens. So now we basically are sliding over by 3, which I absolutely agree with, instead of by 2, and our image is wider. Yeah, okay. Oh, this is also a cool effect, actually. So what people are saying in the chat is that now we need three times as many lines, right? We can't just do 2 columns. We're gonna run into the same problem as before. So we need a third result line in order to have that work. So if we don't have that, we see this really interesting effect where sort of every now and again, but spaced a little differently this time, certain columns are missing. So we can add in another line here, which is gonna be at 3x plus 2. Now think to yourselves, this feels a little funky, right? So as this is running, what if I wanted to change it to 4? Then what else would I need to do? Someone needs a new diet, I agree.
So a lot of great questions about how to make this scalable, like, and a lot of great suggestions on, like, if I want this to be able to work for any stretch, like if we change it to 4 or 5, we'll have to write this line 4 or 5 or 6 times or something, and that's not scalable.
So yeah, so then the question is, yeah, which I see people putting in the chat, is like, anytime, this is a red alert, right? Anytime you see yourself copy pasting a line of code some number of times based on how many times you want something to happen, you should in your brain think, for loop. It's a for loop. And a for loop will, in fact, be the answer. More loops, always more loops. So let's say that now if I have this number that I want to be using, really what I want to do here is I want some for I in range, and then however many times I want to loop. So in this case, 3, right? Then I could basically slide these over, and I'm only going to need to do one of these lines, right? Because now this line is going to run 3 times. So then the question is, how do I update this such that it sort of uses the information from the for loop? Exactly. We basically want to add in I. Because now instead of being +1 or +2 or +3 manually, what this is doing is it's going to say, okay, I'm going to start at +0, and then I'll do +1, and then I'll do +2, and it'll do it exactly the right number of times. So in theory, if we just converted this for loop correctly, yeah, now we're correctly scaling. So fantastic, but we can take it one step further. I see some people saying, well, it feels bad that we're hard coding this 3. Like, that's not good style. We don't want to be hard coding this 3. So more suggestions in the chat. How could I sort of make this a variable that's like changeable? That maybe makes this a little bit more versatile.
People are so on top of these suggestions. It's amazing.
Like, I know, you all are really killing it. Yeah. Ooh, okay. So we have actually we have some competing options here. I see variable, I see constant, and I see input. So all very good options here. So so I'll talk through each of these in turn. So input is a really good idea of like, maybe I can ask for input from the user. So I really like that idea, and we absolutely could. It's a little bit of overhead to like convert it into a number and make sure that they're putting in the right thing. And I would argue that maybe that isn't something to do inside of make stretched, right? Like maybe if I was asking for input, that's kind of like separate from the actual make stretched functionality, right? Like that's sort of somebody else's job of like, really make stretched, its whole job is to like take some information and output an image. So it shouldn't really worry about interacting with the user. So I agree, we could ask for input, but I don't think that's gonna help us here. So then option number 2 is to make a global constant, which I 100% agree we could do. So we could do like scale equals 3, right? And then instead I could sort of do scale here, and I could put scale here, and I could do scale here, which is also super nice, right? So now we've sort of moved that, and I can just manually as a programmer, I can like set this to 4 or 5, and in theory, this should now run the way that I want it to. But again, what this means is that within an individual program, like I can't change scale, it's a global constant, it's not gonna change. So what this means is that every time I'm making an image stretched, I have to make it stretched 5. So that's where we come to our last option, which I think I'm going to use a slightly different terminology here. Rather than variable, I'm going to call this a parameter. Because imagine if I wanted to, in main, make a couple different stretched images that I could see side by side. Like maybe I wanted the first one to be scaled by 2, scale by 2, and then the next one I want to be scaled by 3. That would be super useful functionality to know, right? So the question is, how can I have main tell my make stretched function how much to actually stretch this by? Because that would be really useful for main to be able to communicate to this make stretched function. So thoughts in the chat. How might I be able to tell, make stretched, how big to make it?
Additional parameter. Nice.
Yay, great. So I use this keyword parameter, so hopefully that is a meaningful keyword. Exactly. So what I can do is I can add a scale parameter. And so what that's now saying is make stretch is going to also take in information about how big it wants, whoever's calling it wants the image to be. So I can update all of these to be this parameter here, scale, scale. And here, now we have to sort of pass in the information, right? So that's a simple image. But here, so I can instead say, you know, I want this to be scaled by 2. And then here, I want this to be scaled by 3. And if we have correctly constructed our magic here, in theory, we'll see the original, then we'll see stretch by 2, and then we'll see stretch by 3. Yeah. So we've taken all the iterations of how to make this code more and more versatile. And I think this iterative development strategy is a really good way to think about your code. It's like start with a simple thing, start with something you know how to do, and then after the fact, figure out how to like increase the complexity and the versatility of the functions you're writing.
Amazing. Wow, so great.
Oh, wow, we're so powerful, team.
Yeah, that's such a cool program. Like you can make it stretch however much you want. It's cool, right?
Just for the sake of argument, let's see what happens if I do this.
Oh my God, that's gonna crash the computer.
It might, we'll see. Simba's not a very big image, so we might be in luck here.
Okay.
Yeah.
Like yeah.
Simba's looking great. So yeah, Simba's not having her best day, but so it goes.
Yeah. So there's a good question. Does scale have to be an integer? Very good question.
That is a very good question.
Right.
Yeah, so let's think about it. So our strategy here was to sort of manually copy over 1 pixel for basically an extra pixel for each scale that we're doing. So like we did scale 2, we copied it over twice, scale 3, copy it over 3 times. So in terms of thinking about like non-integer scales, it starts to be quite a bit harder to reason about, because what it means is that sometimes we want to copy it over and sometimes not, right? Because in the case here, I'll actually draw a picture. So let's say we wanted to scale it by 1.5, right? We had this original image, A, B, C, D. And in order to, this was a size 2. So size 1.5 would be size 3, right? So what we probably want is something like A, B, and then C, C, D, where like we only copied over the A and not the B twice. But it's kind of unclear, like which A should we copy the A twice or the B twice, or like which column should we leave out? And then it starts getting even harder when you scale into like, I don't know, like 1.6 or 1.7, where it starts to get pretty tricky to reason about how to copy over those, which pixels to copy. So the answer is absolutely, like programs do it all the time where you scale by not a perfect factor, but that logic becomes a lot harder because now you have to start making choices about when do I skip pixels, which pixels do I skip, how much do I copy them over by, and so on and so forth. So I encourage you to try thinking about it on your own time, because I do think it's a really interesting question. And we have a lot of respect for Photoshop now and how it's able to scale things. Yeah, so the answer is yes, you can, but it's much harder to reason about.
Other questions? What about shrinking the image? Good question.
Ooh, oh, really good question. Okay, well, let's take a similar example. So let's say I have an image now that's like 4x4, A, B, C, D, and I wanted to scale it to half. So this is going to end up being sort of a 2x2. Thoughts on what might go in this box? Maybe just we'll worry just about the top row for right now. What pixel values could end up in there if I was shrinking it by half?
So that's a good suggestion.
Okay.
Many good suggestions.
Really good suggestions. So there's like 3 relevant suggestions I see, which is 1, I can basically just take A and C and copy those over. So I can have AC, which I agree. Basically, we slice out sort of individual columns in a similar way we actually saw. It's like the inverse of our stretching by columns. And so we sort of lose information, but we end up with a scaled down image. I think that would absolutely work. That's a really good way to do this. Another option we saw is to maybe be smarter about our conversion. So rather than just losing information, maybe we do the average of A and B and put that in here, and we do the average of C and D, and we put that in there. Also another totally valid strategy, because that way you end up with a slightly blurrier, maybe a slightly blurrier image, but you don't lose as much. It's not gonna be like as hard of a contrast between all the pixels. So I think both of those are totally reasonable. And again, it starts to become an implementation question of like, which one makes more sense to you? What's the desired effect that you are looking for? Really, yeah, good thinking, good questions. And I think it's worth just thinking about like which of these makes more sense to you, which one you think would create a prettier result, or like what you might be going for. But it does come up with the same questions like which pixels do we drop? How do we incorporate all the information that we need?
Yeah. There's a question, someone saying, could you explain the logic behind needing multiple lines for result image.setPixel? Why do we get those empty lines when those other pixels are missing?
Really good question.
Maybe we could go to the slides.
Yeah, that's a good idea.
Because the blank ones actually come up in the slides.
Yeah, no, absolutely. Okay, yeah. Can we see this?
Yep.
Fantastic. Okay, so I'm going to draw on this a little bit. So let's think about what happens when if I just have that one result dot set pixel line. So we have one sort of result dot set pixel. If we think about our double for loop, what's happening is I'm going to visit once each of these pixels, right? So I'm going to have my XY at 0, 0, and then I'll have my XY at 0, 1, and then I'll have my XY at 1, 0, and so on and so forth. Those are not in the right order, but you get the idea. And so what that means is that literally based on the size of this, my for loop is going to run 4 times, or my doubly nested for loop is going to run 4 times. So if I only have one result.setPixel line, the biggest number of pixels I could possibly copy is exactly 4. I'm only going to be able to set 4 pixels here, which means I'll be able to set this A, I'll be able to set this B, because we're scaling, we're doing this like 2x thing. And I'll be able to set this C, and I'll be able to set this D. But the result.setPixel is, since I'm only calling it once, like there's no way that I can physically like actually be able to set more pixels than that. So in order to actually be able to set like 8 pixels instead of 4, I need to be calling my actual set pixel line more than once. So I need to call it again, this time on 2x plus 1, because that way that actually lets me sort of then tack on that extra 4 calls that I need in order to access those columns. But yeah, it's literally just a limitation of this for loop that it's only running 4 times. So if I only have the line once, it's only going to be able to copy over 4 pixels. Really good question.
So those blank kind of vertical lines are coming up from the fact that like we're leaving literally gaps in the new image.
Yep, because we're moving over by 2x each time. So this is like 0 goes to 0, 2 or 1 goes to 2, but we didn't have anything that hit 1 in our original version. So 1 is sad and alone, the entire column.
Cool. I don't see okay, there's some fun questions.
Okay.
Maybe we can close off with those. So Anya asking, where can we learn about how content-aware scaling works? That seems like a really advanced version of this. I would say Google is your friend. Like, I'm not even sure. I think you could just search like Photoshop content-aware scaling algorithm, and you'll find someone writing about how it works or some blog post. Usually that's a good way to figure that out.
Also, read people in the chat. This is the end of our like scheduled content. We'll take a couple more questions, but if you need to go, we're not keeping you here by all means. We'll keep recording, so if you care about catching the last couple of questions, you can watch it later. But thank you everyone so much for coming today. It was fantastic to have you. I think this is the last of these that we're doing, because after this is just your project. So thank you for going on this wild adventure with us and experimenting and seeing what happens. It's ended up being a lot of fun, so we really loved having you.
This is truly the most fun thing about the class.
Oh yeah, by far. This has been great.
Because it's so great. Because when you answer the chat, it's like you're right here. It's really great.
I know.
Yeah.
I feel so connected.
We're right next to each other.
Yeah. Together, but apart.
We are social, not distancing.
Yeah, we are. Yeah, social coding, distancing, in place code, in place distance code.
A cool question. Well, it's a fun question. Evangeline asked, I'd be curious to hear if the instructors could explain at a high level what is going on when you use portrait mode to take a picture on an iPhone. So this is a really cool question. I like this question because these are really things you should be thinking about. You have learned enough about images that you can do really, really cool things. For example, saw in lecture how to do a green screen. That's kind of how Zoom's virtual background works, you know. So it's really powerful. Like you can do very cool filters, like all of those Instagram filters that are a big deal. You could probably implement yourself in some way. So yeah, like a good question, like how would something like portrait mode work? Well, it's actually it's not that different from our like is dark enough thing. You can kind of think the pseudocode. Maybe Maya, you can write this.
Yeah, absolutely.
Yeah, like the pseudocode is like for each pixel, right? So yeah, like if you really wanted to reason about how something like blur background or portrait mode might work, you could say for each pixel, yeah, if that pixel is part of the background, you know, then blur the pixel, else leave it, or maybe sharpen it or make it like brighter or something, because it's your lovely face. And then it's the same, right? Like you could have a function called is part of background that returns true or false based on whether that pixel is part of the background. And okay, maybe that function it's not easy. Like maybe you can see if that pixel value is sufficiently different from a skin looking pixel or something, or a face skin looking pixel, and return true if it's sufficiently different and false otherwise. And then how do you blur it? Well, we talk about blurs. I think some of the extra challenge problems in the assignment are about how to blur, right? So, and this is really like how you would do this. You would do something exactly like this. And the cool thing is like you're using this function is part of background, and that function can be as simple or as complicated as you want. It can be checking this difference from face color. You can use a deep neural network to return true or false in that function based on whether it's part of the background. That's usually what these portrait modes are doing. But the point is when you decompose, like you can sort of take out a piece and replace it with a more complicated one without having to change the rest of the code. So all we'd have to do is change that is part of background to be a deep neural net, and then it would be great. You know, so it's a very good question. Yeah.
No, you are equipped to be so powerful now. With these tools that you've learned, like the sky is the limit. It's just a question of slightly more complicated algorithms or slightly more interesting pieces getting thrown into the mix. But like you know how to change an image, you know how to apply filters and scale things. So go forth.
I need some example.
Oh, so also a couple bookkeeping things. And oh, actually, I see an interesting question from Georgia, so we'll get back to that. But bookkeeping things. First of all, if you ever want to like add in your own images, this like assignment 3 folder in PyCharm is like a folder on my computer, right? And then it has this like images folder inside that like project folder. So if you add images to that images folder, like on your computer, then you can access them from your code by just like passing in, you know, images and then basically like saying, here's the subdirectory and then here's the, here's the image that I care about. So you absolutely can pass in your own images and like, you know, do modifications and have fun with that. All you have to do is put them in the folder on your local computer. Pull up the Q&A here. I think we answered that.
I'm not sure what that means.
A couple questions about whether or not the website is going to be up after the course finishes. I actually have no idea. Ollie, do you know the answer to that question?
Probably it will be up.
I assume it'll be up at least for a while. So I doubt this content will be taken down anytime soon. It might be taken down if, like, for instance, another run of the class happens at some point and like they want to like start fresh or something. But for now, I would say it's not going to be taken down immediately as soon as the class ends. Like, we understand that people are on a different schedule. So
and definitely we will not put you in a position where you don't have access to like the simple image library or things you want to mess with on your own time. So we'll set up something for you to have access to all of that.
Yeah, don't fret, team. Okay, 2 interesting questions. One, how can we apply these skills to video editing? Really interesting question. That starts to get quite a bit harder. But if you think about it, a video is basically just a consecutive stream of images, right? It's just a bunch of different frames. So if I were to apply a filter to each of those individual frames, that would be very similar to applying a filter to the entire video. It's exactly what it would be doing. So I don't personally, I've never written any code to apply filters to videos, but I would assume that if you had if you put it together, this sequence of images and applied filters to each of those images, then you could sort of apply that filter on the fly. That's what frames per second stands for exactly. And then the next question I saw is, never mind, I lost it. I'm not sure where it went, but.
That's what I feel.
So I see how do we use all these programs in real life, TM? Can we make a Python program work on an HTML website like we do with HTML or CSS? Very good question. So all of the skills that you're learning right now, even if you don't like specifically use these very programs that you've written, what you've learned is how to like read and write and think about code. So once you've learned your first language, learning your second language is like truly so much easier. It is not the same as normal real world languages. Learning Russian maybe doesn't help you much with Spanish, but learning Python helps you a lot with JavaScript, or so on and so forth. So like a lot. So there are ways, first of all, to run Python scripts from a website. That's absolutely possible, and I recommend you look into WebDev. But also, you can run JavaScript scripts, and JavaScript looks a lot like Python. There's a lot of things that are very similar between the two. So you're now equipped with the skills to go forth and learn basically anything that you want to then be able to like construct these quote unquote real world anything that you see like that is a problem that you can solve because you now have the skills to start thinking about and reasoning about these problems, which is the important part anyways.
Yeah. I see a question. How do we save our images? So I think the simple image library doesn't have a save function, which is kind of unfortunate.
That's really sad.
But there's an ed post about this, which you can just look up just search save image in the ed, and it'll come up, and it tells you how you can save an image, or you can just take a screenshot. That's also a thing you can do. But
sad. RIP, simple image. But yeah, I usually just take screenshots whenever I want to save. That's how I made this slide of Simba's. I just took screenshots of 2 images. So
cool. Okay. Do we have a favorite programming language?
Ooh. It's a hard question.
That is a hard question. You go first.
Okay. So actually, it very much depends on the application. Like each programming language is usually very finely tuned to whatever you're actually trying to do in it. I love Python personally because of how easy it is to go from an idea to like a result. There's a lot of overhead in other languages that is just super annoying and gets in the way. And so other languages are better, I think, for building big, like large scale applications. But Python, if I just want to go from like I have this data set and I like want to ask some questions about it, Python is always the easiest way to ask those questions. So right now I'm like a full Python convert. I love it dearly. But as a systems programmer, it would be remiss of me to not give some love to my lower level languages. I can't say I love C++. C++ is too bad for me to say that I love C++, but C++ is also good. And I think Rust is probably the future. So I got to give a shout out to Rust too.
There's really the right answers. It really depends on what you're doing.
Yeah.
You find that there's often a big divide between what your favorite programming language is and what you use most. I use Python a lot. I mean, pretty much always, just because it's very easy to get things done with Python.
Yeah.
And it just like doesn't get in your way ever. But when you're writing like software for like industry or something, like Python has its little quirks that make it hard to use sometimes. Personally, depending for ML stuff, obviously Python. For machine learning stuff, obviously Python is my favorite. For system stuff, I love C++, but that's more of like a self-hate type of love.
It's like a bonding through trauma kind of love.
Yeah, it's a bonding through trauma type of thing. And my favorite, I guess, full stop are functional programming languages like Scala or Haskell.
Yeah.
They're very mathematical and I really, really like them. but they're not. I mean, they're not very useful. They're really.
I've come around to functional programming languages. If you're ever curious, functional programming is like an entirely different paradigm and different way of thinking about how how functions chain together and how objects work and everything. It's very cool. But very, very, very difficult to learn. I had to take 3 classes before I could even claim to begin to understand how functional programming really works.
It's really a mindset change. Like, it takes some time, but yeah, it's cool. And there's a really fun language called Fish, which is a visual language that like bounces around symbols. It's a fun language. You should check it out.
And also, I saw a question from Rena. Yes, you absolutely can call yourself Python programmers now. Look at the complexity of what you're accomplishing. You're absolutely Python programmers. No, you crossed that bar a long time ago. So congratulations. You are programmers far and beyond. This is the kind of thing that you're able to do is so cool at this point. So congratulations. Pat yourself on the back. You win. You did it.
So many good questions. I've heard that C++ is faster than Python. So again, like we said, it really depends on what you're doing, right? Like when you're writing an operating system, like milliseconds really, really matter. Or when you're writing like the code to run on a tiny little microchip on your iPhone, it really matters whether you use like 1 kilobyte extra or not. And so you write those programs in languages which give you really fine control over like where bits of memory are going and how fast. And C++ and C and Rust are kind of those languages. So for operating systems, usually things are written in them. It's harder to write code in them, but you also have more control. It's like a manual car. Like it's less easy to use, less user-friendly, but you can do better things with it. So it depends, right? But like in our day-to-day, we don't really need speed to those milliseconds. We'd rather have I'd rather have it that it takes me like 3 hours less to write the code and the code runs like 10 seconds slower than like, but for operating systems, that's not the case. Like they will spend months and months to shave off like 3 milliseconds, so it's just a different trade-off that we care about.
Yeah, it's about the time put in up front versus the reward at the end, right? It's a cost analysis of like if the benefit of 3 milliseconds, if your code is going to run like 1 trillion times a day, the benefit of 3 milliseconds might make a huge difference. Like if you're running Google servers and like you really need those 3 milliseconds, then like it's probably worth the overhead and the time put in from an engineering perspective. But if you are, if you're running your code once or twice or maybe even 10 times, 10 seconds isn't going to make a huge difference because you're just running it for you. It doesn't end up changing much. So really, good thinking there. I also saw a question that was just like, what would we recommend going forth after this class? Like after you taking the skills that you've learned, how to continue learning Python and like apply what you've learned and keep going, which is a very good question. So I also think the class will be outputting some resources afterwards that'll be like recommended at a higher level.
Yeah.
My personal advice is honestly like find a problem that you're interested in and like see if there's a way for you to solve it. Start reading online documentation, look at other people's projects. Like for instance, I play a lot of Dungeons and Dragons, fun facts about me. And I had one of my favorite moments of all time was we were playing a session and our dungeon master gave us a puzzle that we had to solve, which was kind of like Towers of Hanoi, where you had to like sort of flip things back and forth. And I really didn't want to solve the puzzle on my own. I was annoyed about it. So I sat down, I was like, I bet I can write a Python program to solve this for me instead of actually sitting down and manually working out by hand. So it turned out that was slightly slower than the other person in my group solving it by hand. We got to the same answer at the end. But now I have a program that can solve any of those types of problems. And that was just me sitting down and going, I wonder if I can like write code that will do this thing for me. I'm just curious. Let's see if I can explore this. So like look for opportunities in your life. Now you have a tool set. You can apply those tools anywhere. And as you sort of do this more, the set of problems that you're able to tackle will grow and grow. And eventually nothing will be out of reach. So just look for opportunities in your life and find times to write tiny little Python programs and your knowledge will only grow.
Yeah, I second that very, very hard. That's pretty much, I think the single best way to get better at programming outside of like, taking an initial class to build the right foundations and style is to just take a project that you care about. It can be anything. It can be really silly. and just write something to do it. And it doesn't need to be sophisticated, it doesn't need to be pretty, but just you'll notice that as you work on a real project, it'll be very stop-start. You'll hit a wall and you'll be like, I have no idea how to do this. And then you look up things, and and it's not something you should hesitate to do. You're very much equipped to do those kinds of things right now. Like you are 100% Python programmers, and really in like, I would say very reasonably like 6 months of a timeline from here, you could work in software engineering as a like job if you were really like persistent about it. That's not at all an unrealistic statement. Just to give an example, like Maya's Dungeons and Dragons, when I had never programmed before coming to undergrad. I took 106A with Mehran, and I remember after finishing the class, I was just like really curious about, I was having an argument with one of my friends about what makes great literature really great. And my friend was saying, well, it's really like the content, right? Like great books have a really cool story or something. And I was like, okay, that's probably true, but I really think it has to do with like the writing style. Like good authors have very interesting writing styles that connect with people. Like they describe emotions and feelings in a really like deep way that connect with people. And so to prove her wrong, I was like, I looked through all of Project Gutenberg's free books and like did this similarity of words or something. And it was all like totally clueless to it when I started, but it was like very, very insightful since then. So yeah.
Wow, what a profound example compared to my I wanted to solve a puzzle in
Oh,
Dungeons
no,
and
it was so
Dragons.
dumb. It was like a little like just a little like discussion about like the philosophy of great literature, and I was like,
Right. And you were like,
maybe
I bet
there's
I
a
can.
way. Yeah,
Well, and
the
that's the
results are
best.
inconclusive.
Yeah, that's the best feeling is when you like have this tiny problem. You're like, honestly, I'm like a little bit curious about this one. Not like super curious, but a little bit. And then you spend like 4 hours dumping like time into researching and writing a solution. And in the end, you like get an answer to your question, like, wow, that was neat. But then like ultimately what you did is you just had a lot of fun writing this like interesting solution to this like tiny problem. So I've definitely gotten carried away and spent like 10 hours, 15 hours writing something that just truly was inconsequential, but I was just having fun doing it along the way. So it's always a good time.
Yep, exactly. Cool. I
Okay.
think we're dying down.
Looks like most of the questions have filtered out. I'm sure there are a lot of also just good online resources. So I recommend, like honestly, if you just like look up learning Python online, there's like 1,000,001 different tutorials presenting things from different perspectives. So now you have the tools to engage with all of those and know what they're talking about when they explain things.
Right.
So you're well equipped to do whatever online resources exist.
Yeah, and it's fine to look for domain-specific things that you care about. Like if you want to learn how to write a web app, or you want to learn how to do finance stuff with Python or something, you can always look up like,
right, like
using
Python for finance. Yeah, my favorite thing that I learned how to do with Python is to interact with web pages. So like be able to basically like send web requests and like grab web pages and navigate them via code. Because now what I can do is I basically have set up little automatic sign up scripts for myself. So that like, for instance, I was in an exercise class last quarter at Stanford, and you had to like sign up at 8 a.m. in order to get into the class. And I was really annoyed about it. I did not want to wake up at 8 a.m. in order to be able to get into my class. So I wrote a little script that just automatically signed me in and like signed me up for a class the day before, which was, you know, fundamentally changed my life for the better. So that was my little like tool. And I was like, nobody's stopping me. It's not against their policy. I looked. They didn't say it was against the rules. So.
Oh my God. Yeah. And you're, again, to reiterate, you're very capable of doing stuff like that. Like set high expectations for yourself. This is not like a like baby intro class. This is like real programming. So.
Okay. Yeah. Thank you, everyone. I think we'll probably call it here. It was delightful to have all of you. Thank you so much for showing up and interacting with us. This was a really fun format. And hopefully you feel well equipped to tackle assignment 2, including all of the extra bonus problems. I think you have all the skills that you need at this point.
Yeah.
Okay. Great. Bye, team.